Hello, today we're going over calculating speed of the Hawaiian Ridge and Emperor Seamount. And it talks about these two features extensively here, and we have a map also here that we're going to be looking at. But Hawaii is down here at the bottom of this map in the Pacific. And there's a few islands, the Hawaiian Islands, that go in a string for several hundred miles. But the island chain actually extends much further than that, going out towards Midway Island, quite a bit farther away, over 1,000 miles away. And the way that these islands were created was from a hot spot, but the plate on top of the hot spot has moved over time. So as we go down this chain, we get older and older islands. And eventually we get to a point where they're no longer islands, but they've been eroded away and they're underwater seamounts. So kind of like a mountain that's just below the surface of the water. And that goes back further and further until we get to a spot where it's 81 million years ago is when this one was formed. So at one point, all of these places were over this same spot, but we can see that the plate moved and it even changed direction. So for a while, it was running in this kind of north-south direction. And then more recently, it's running in this east-west orientation. Okay. But what we're doing here is we're just practicing calculating speeds. So for speed, here's the speed formula. Speed equals distance over time. Well, we have time because we know how old some of these islands and seamounts are. And this is in millions of years. So this is 5,100,000 years. This is 19,900,000 years. But we don't know the distance. So we need to measure the distance. And the first one we're going to measure is Kauai. Now we're measuring from Hilo, which is the big island, which is the active modern island. That's a city on the big island of Hawaii, is what I should say. And the way we're going to do this is we're going to look at our map, and there's a scale down here of 500 miles. So you can use a ruler, but you don't have to use a ruler. I'm just using a piece of paper because I know that on this map, this distance from these two lines is 500 miles, and we're just going to estimate. So here's Hilo on the big island. And I want to know how far away Kauai is. Well, Kauai is here, and I know this whole distance is 500. Well, it's not quite 500, right? Halfway is about 250. It's a little bit more than that. So I'm going to say that's 300 miles away. So I put my distance 300. And now I'm going to use this formula to calculate the speed at which that island had been moving over time. So distance is 300 divided by time, which is our 5,100,000. And then I can calculate this to see how far it moved each year on average. And we get 0.0000, so 4 zeros, 5, and I'm going to put 5.9 because I'm rounding it. And that's m/y, miles per year. So on average, it doesn't move very far. That's just a fraction of a mile every year. But over 5 million years, that distance that it moves becomes pretty significant, 300 miles. Let's do one more. The next island is Laysan. So here's the island I'm pointing to. And I'm going to start at Hilo again. So that's 500 miles. And then I move it forward. That is not quite another 500. So it's not 1,000 miles. It looks like it's maybe around about 900 miles. And I'm going to do the same calculation. 900 divided by the time that I have up here, 19,900,000. And that's going to give me 0.00045 miles per year. And so we came up with another average of how fast that island has moved away from the hotspot. And you're going to do the same for all of these. Remember, you're estimating the distance. It's not going to be perfect as you count these up. But you know that this amount is 500 miles, and you just keep going 500, 1,000, 1,500, 2,000, and also then going up that way when you do those islands. Okay, if you need any help, let me know. Thanks.